Yes, good morning, good morning, good morning, good morning. So, all good? Okay, all fine. Okay, so what things we have completed in last class? How much completion? Uh, you practiced few questions from VRMS because we did the VRMS things because this week. Good afternoon. Yes, yes. Good afternoon. Few questions from VRMS. Okay, I hope you got all the questions. What was the reference material you have? Okay, you tried. Because today we don't have much syllabus. Syllabus is questions on PDF, question on DOF 1 to 2. Okay, DOF is actually means directly questions on the degree of freedom are very less. Okay, they can directly ask what the degree of freedom. Okay, for this month, for this month. So that is okay. Uh, Means major questions are not there. Okay, they can ask like for oxygen at high temperature, how many vibration? For oxygen at high temperature, for oxygen at high temperature, degree of freedom, you can say 2. Okay, if I say for solid, okay, I can ask like this for solid. Okay, for solid basically how much degree of freedom? For solid, what will be the degree of freedom? For solid, degree of freedom will be, you can say, sir, degree of freedom for the solid will be 6, because solid molecule is okay. Solid structure we can say here this way. In a case of solid, each atom, if you say each atom is connected in all 3 dimensions with other atoms. Okay, in all 3 dimensions, anyone you can take like this one. Okay, all 3. Okay, and we can take these as spring. So we have 3 mode, and okay, 3 mode means how many degree of freedom? Your 6 degree of freedom for solid. Okay, for solid 6 degree of freedom is 6, because we can see 3 modes are there. Okay, so like these questions can be there in the degree of freedom. Okay, this one if you're not written, then you can write. Okay, you can write this one if you are not written. And in the last class we have done Maxwell energy equipartition of energy. That's Maxwell law of equipartition of energy, that was completed. Energy for each degree of freedom for a molecule is half kT. Energy for each molecule for each degree of freedom is half kT. That was done now. Yes. Okay, so we can say for each molecule for each degree of freedom is half kT. Okay, so if okay, this was done. Then we said internal energy. So we got the formula F by 2 nRT. We then got F by 2 nKT, and we got this one as F by 2 PV. Okay, this was also done. F by 2 nRT, F by 2 nKT, F by 2 PV. This also done. F by 2 nRT, F by 2 PV, and F by 2 nKT. This also done. Okay, I said then delta U. So delta U equal to will be how much? Your F by 2 nR delta T. F by 2 nR delta T. This also done. Delta U F by 2 nR delta T. Somehow 6. In case of solid, each atom is connected in all 3 dimensions. So you can see, sir, these are the 3 springs we can assume, and for each spring we can say 2 degree of freedom, one for kinetic energy, one for the potential. Here Kp, here Kp, here Kp. So total modes will be 6 degree of freedom. Okay, total are the 6 degree of freedom for each vibration mode. 2 degree of freedom there. Okay, this one also done. Okay, and then we have done, okay, for ideal gas. Okay, for ideal gas, okay, it is always point mass. Okay, for ideal gas, okay, molecule is always point mass. So this thing we are written for ideal gas. For ideal gas point mass, I think this one not written. For ideal gas, how much degree of freedom will take? For ideal gas, degree of freedom will be 3. Okay, we'll start from here. For ideal gas molecule is taken as point mass, and if this is taken as point mass, then we can write how many degree of freedom will be there? 3, because point mass means just like the monoatomic, and if just like the monoatomic, there is no rotation and there is no vibration. So degree of freedom for ideal gas is, how much degree of freedom we take for the ideal gas always? 3 degree of freedom we have to take for the ideal gas. Okay, degree of freedom for the ideal gas is always 3, and if this is the 3, then we can see, because only translation is there, that's why we write energy of the ideal gas is only translational. Energy of the ideal gas is, okay, purely translational, because there is no rotation and there is no vibration. Okay, so purely translational. Energy of ideal gas is purely translational. Okay, and this one we can write here, it will be the 3/2 nRT, as well as we can write 3/2, okay, 3/2 PV. Okay, we can say 3/2 PV, or we can say 3/2 and KT. Okay, so this is the formula for ideal gas, and we say ideal gas energy is purely proportional to, it will depend on temperature. Okay, it will depend on temperature. Potential energy for the ideal gas is 0. Okay, potential energy is 0. So we can write here in this one, E1 by E2 equal to how much here? T1 by T2. E1 by E2 equal to T1 by T2. Energy of ideal gas is purely, energy of ideal gas, okay, ideal gas is purely translational. Okay, translational kinetic energy. Energy of the ideal gas is purely translational kinetic energy. Any potential energy, what the potential energy in the ideal gas? We can say 0, because there is no vibration. Okay, no vibration. Okay, so and energy depends on temperature. Okay, already I said that kinetic energy depends on temperature. Okay, so if I say at 0 Kelvin, then kinetic energy is always 0. 0 Kelvin is the temperature of 0 energy or 0 kinetic energy. 0 Kelvin is the temperature of 0 energy or 0 kinetic energy. 0 Kelvin is the temperature of 0 kinetic energy, you have to remember. Okay, not, okay, we cannot say total energy, because total energy means your kinetic as well as potential may not be 0. Okay, so we can say total energy. Okay, we'll say 0 Kelvin is the temperature of 0 kinetic energy. This thing you have to remember. So I hope now we are ready for the questions. Yes, for the real energy, a real gas, you will take total energy, kinetic as well as potential, but for the ideal gas, potential is 0. Okay, if I say here energy density, okay, so we can write, sir, energy density is nothing but the energy by volume. So ED will be equal to here energy by volume, and for the energy I will use the formula 3/2 PV divided by V will be cancelled. So ED is always equal to 3/2 P. Okay, we can say energy is always equal to, energy density equal to 3/2P. Energy density equal to 3/2P. Sometimes they will say pressure equal to, they will ask pressure equal to. So we can say, sir, from here I can write in this one, pressure equal to, so pressure will be equal to, here we get 2 ED by 3. Okay, T ED by 3. But ED is here energy density. ED is the energy density. You have to remember this thing. ED is the energy density. Okay. Up to this, any problem? Ready for questions? Can we do some of the questions? Yes. Some questions can we do? Okay. Yes, very good. Okay, so let's write some of the questions. Okay, here they will ask, if they have given pressure volume, then we'll use formula PV. Okay, like here we have seen these. Okay, we have seen the formula in terms of PV. So we'll use PV. We can use, okay, like this. We can do the things. Okay. So now we have a question here. First one, find energy of 2 mole O2 at 27 degrees Celsius. 2 mole oxygen at 27 degrees Celsius. So now we can write here, sir, in this one we'll use the things U equal to, formula is F/2 and RT. What is the degree of freedom for oxygen? This is degree of freedom for the oxygen is going to be, degree of freedom for the oxygen is 53556. 3556. So degree of freedom for the oxygen is 5. So I will put here 5/2. Okay, and then I can say N is how much here? 2, and then I can write your RT, so 2 to cancel, so this becomes actually 5 RT. Now if they are asking answer in the joule, we'll put 25 by 3. They're asking the calorie, we can put R as 2. Okay, so I will calculate both way. So I will say here 5 R 25 by 3, R T is your 300K, so I guess this becomes here 100. 25 into 100, if you say, so 25 into 100 is the 125, and this becomes finally here 1250 joule in joule. But suppose they're asking the calorie, then R value will put as 2. Okay, so you say equal to 5 RT here energy. I will put 5 R as 2, T as 300. So now we can say this becomes how much here? 3000. Okay, calorie. Okay, so they can ask in the joule as well as calorie in any question they can ask. Yes, can we do? Okay, we can do the questions. Ready for next? Okay, let's write next question now. Okay, Maruti and Harsa. Okay. Now, so we'll do the next one. Here I have given one gas, okay? One gas. Now I will take two gases, okay? Here only one gas is given. Now how to give two gases, and then three gases, and then four gases, okay? Let's do the things. Yes. So we can say here, okay, find total energy, okay? Find total energy, okay? Find total energy of some of the samples will be given, okay? Old students, okay, enjoy your life outside now, okay? Chill outside, so many things are there. Okay, so we can say find a total energy of two gases will be given here in this one. They will say 2 mole, okay, 2 mole monoatomic and 4 mole diatomic, 4 mole diatomic at 27 degree or nothing, okay? I have not given temperature. If I give you temperature, you can find. So we can say here in this one, U equal to, you can say, sir, will be U1 plus U2, okay? It means we can say for monoatomic as well as for the diatomic, for both we need to find we have to find the energy here for the mono. So for the mono, we can say degree of freedom is 3, so 3 by 2, and moles for the monoatomic is 2 here, okay? So we get 2 RT. Plus I can write here in this one for diatomic 5, so 5 by 2. Moles for the diatomic is your 4 moles. So we'll write here 4 RT. Now we can say 2, this will be 2 to cancel. So this becomes 3 RT plus 10 RT. So finally answer becomes here in this one your 13 RT. Okay, means we have to write for, okay, for the mono also as well as for the di, okay, mono and di both we have to write. So for the mono we can say 3 by 2 and moles 2 RT, and then for the di we can say degree of freedom 5 by 2, 4 RT, okay. Can we write the next question? Next one. Okay. So now we have here next question in this one. They will say, okay, if they have given the pressure and volume, like I can say in this, okay, in this box, okay, this box volume is 5 liter, and they are saying energy is given here. Energy, this is the 5 liter, okay, in this one. Suppose oxygen is given, okay, 5 liter oxygen, and they have given energy, okay. That is 5 into 10 power 5 joule, okay, 5 into 10 power 5 joule. Then we need to find pressure, okay. They're asking find P. So now we can say U equal to, I have to use formula in terms of pressure volume. So I can use the formula F by 2 PV by 2 PV I will use, okay, and degree of freedom for the oxygen. So this will be the 5 by 2 PV, okay. So I will put the values here. U energy is given, so 5 into 10 power 5 equal to, I can write 5 by 2. Pressure I have to find, but volume is 5 liter, and 5 liter I can say 5 into 10 power minus 3, because I have to do whole calculation in the SI unit. Now we can say, sir, 5 and this 5 will be cancelled. So pressure actually I can write, okay, 2 will be this side, so 2 into 10 power 5 divided by 5 into 10 power minus 3, because this will be going upside. So it becomes 2 into 10 power 8 divided by 5. I hope you can do the calculation. 0.4 into 10 power 8. Can you do the things? 0.4 into 10 power 8 means this becomes, here we can write 0.4 into 10 power 8. Yes? Over. Ready for next question now? 0.4 means 4 into 10 power 7. Can you do like this? This way also we can finish. Okay. So now we'll write the next question here. Is in the energy 3, 4, 5 questions are more than enough. Okay. So we'll write. Okay. They will say compare energy of O2 and Cl2 molecule at same temperature. Okay, at same temperature. Calculate energy of O2 and Cl2 molecule at the same temperature. Okay, so now we can see O2 and Cl2 molecule at the same temperature. What I can do here in this one, okay, at same temperature, how to find? Okay, so you say, sir, U equal to formula is F by 2 and KT, because they are asking in terms of molecules, so how to use F by 2 and KT. Okay, and then I can say in this one, temperature is same, K is same, and they're asking O2 and Cl2 molecules, means one molecule of oxygen and one molecule of chlorine, means O2 and Cl2 means each one molecule. So number of molecules is also 1. Degree of freedom is also same, because both are the dynamic. Cl2, O2 both are dynamic, so we can say 5, 5. So everything is same, and if everything is same, then we can say U will be same. U will be same. So what will be the U1 by U2? You can say, sir, U1 by U2 becomes how much here? 1 by 1. Okay, it will be the 1 by 1. Okay, U1 by U2 will be 1 by 1. Okay, yes. Over. Any problem in this question? Okay. So now we'll write next question here in this one. So if I say about the next one, okay, at what temperature energy of a gas, at what temperature energy of a gas will be twice of energy at 47 degrees Celsius. At what temperature energy will be twice of energy at 47 degrees Celsius? It means what I can say, E proportional to T, it means E1 by E2 equal to T1 by T2. Means if I say initially energy as E, then finally energy I have to take twice 2E. Finally I have to take here 2E. Energy initially E, then here I have to take 2E. T1 I can take 47. 47 is how much here? 320, because I have to put always in the Kelvin. So 320 Kelvin divided by T2 I have to find. So yes, sir, E cancels. So T2 becomes how much here? 640 Kelvin. Okay, this is the answer, 640 Kelvin. And if they're asking the degree Celsius, then we get, sir, this will be the 640 minus 273. Okay, we can write this one will be the in degree Celsius. Ready for next? Okay. Now, if I mix some of the gases, they will say gas A and gas B are mixed. Okay, so we'll do here one question on the mixture where we have to find the temperature. Okay, so ready for this one? Next question. Okay, 640, yes. So they can say like this, E1 by E2 equal to T1 by T2. Some of the questions we can solve these one also. Okay. We have here, they are saying gas A. Okay, this is the gas A. Its degree of freedom is F1, N1, T1. They can give any gas, like 2 mole oxygen. Okay, so we can say degree of freedom will be 5, 2 mole means 2 mole temperature, they will say 27 or something. So F1, N1, T1. And this side I have taken here B, and B is basically F2, N2 and T2. And then they will say we are mixing these gases. We are mixing these gases, then what is the temperature? We can say, sir, one thing we'll do, energy before equal to energy after. Because when we are mixing, in the concept of mixture, in the calorimetry also will say energy before equal to energy after, because energy remain always conserved. Energy remain always conserved, okay? Yes. So now we can write here in this one, if I mix these two, okay, so we can write here in this one, For A will remain, a degree of freedom will be F1, moles will be F1, only temperature will be the T mixture. And for B also I can say degree of freedom F2 and 2, temperature only will change T mixture. And then we can say energy before mixture equal to energy after mixture, means we can write here in this one energy before, okay, equal to, we can write here energy after, okay. So if I write energy before equal to energy after, before we can write F1 by 2 N1 R T1 plus we can write F2 by 2 N2 R T2. After we can write F1 by 2 N1 R T mixture, and here also we can write F2 by 2 N2 R T mixture. You can say R by 2 will be cancelled from everywhere, okay, cancelled. I need to find T mixture, so directly we can write here in this one, T mixture will be equal to, you can say F1 N1 T1 plus F2 N2 T2 divided by, we can write here in this one, F1 N1 plus F2 N2, okay. So this is the formula, they can ask that formula or they can ask the question also based on this thing we can use, okay. Yes. Sometimes in terms of molecule they can ask. So in terms of molecule I can write the same formula F1 N1 T1 plus F2 N2 T2 divided by, we can write here in this one, F1 N1 plus F2 N2, okay. In terms of molecule also we can write this one, okay. Yes, over. So can we write the next thing now? Okay, specific heat will take in the after calorimetry will have thermodynamics, and there will take the questions on the specific heat. So specific heat, some of the questions are there in the exercise that will be included in the thermodynamics, CV, CP. So in which question CV, CP, specific heat is written, you don't have to do, okay. Question in which CV, CP, specific heat written, we don't have to do, okay. Clear? CV, CP, specific heat, constant pressure, constant volume, gamma, okay, gamma equal to Cp by Cv. That question we will not come this week, we'll do next week, okay. So now we'll write next one, mean free path, okay. Right here, mean free path, okay. If I say molecules are never at rest, molecules keep on moving randomly, and if molecules keep on moving randomly, then you know that before making the collision they travel some distance. Like these are the some of the molecules, so we can say it will be going here and then travels distance lambda 1 and makes the collision, then moves here, travels lambda 2, then makes the collision, then moves here, then lambda 3 makes the collision, and then comes here, lambda 4 makes the collision. So we see total lambda m, so lambda m will be equal to lambda 1 plus lambda 2 plus dot 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 divided by n. If I take average of all, that is known as mean free path. What the free path? Distance between successive collision is known as free path. Why we say is the free path? Because molecule is free to move. So this is a free path. And if I take mean of all, average of all, that is known as mean free path. Okay. So you can write average distance between successive collision. Average distance between successive collision is known as mean free path. Average distance between successive collision is known as mean free path. Okay. Now, this is the definition of mean free path. Average distance between successive collision is known as mean free path. If I say these two boxes are there, now you have to, okay, this is the some observation things. Okay, now you have to tell. In this one, I have two molecules which are somewhat bigger size. And here we can say, okay, somewhat a small size. Small means, okay, means here surface area of the molecule is more, here surface area is less. So in which case, in first case or second case, mean free path will be more. Mean free path means to make the collision it has to travel here this much distance and here only this distance. Here surface area is more, here, okay, size is more, here size is less, means here area is less. So in second case, mean free path will be more. In second case, it is more. Means mean free path and size, what are the relation? If size is more, mean free path will be less. Size more, mean free path will be less. Size we can write, okay, with the your area, means area is known as your 4 pi r square. So I can write lambda m proportional to 1 by 4 pi r square. Can I write like this? Lambda m proportional to 1 by 4 pi r square. And once I written in this way, then I can write here diameter of the molecule is given by 2r. Diameter is 2r. So you can see, sir, d square will be equal to how much here? 4r square. So this 4r square can be replaced with the, okay, pi d square. This can be replaced with the pi d square. So lambda m, okay, you have to remember here relation with the radius as well as with the diameter. We can say 1 by 4 pi r square as well as 1 by pi d square. Okay. If I give another example in this box, okay, and this is the second box, first box, second box. Okay. In this one we have only two molecules. Okay. Volume for both boxes same, okay, same volume, okay, and okay, same volume we have taken. In this one I have so many molecules, means here molecular density is more, here more molecular density, and if molecular density is more, then in second mean free path will be, in second mean free path will be less. More molecular means more molecular density, mean free path will be less, means here mu is more. So mean free path less, means lambda is proportional to 1 by mu. Mu is basically what? N by V. Mu is always equal to N by V. So if I put here N by V, then it becomes your V by N. Okay. Means these are the two relations, and if I combine both, then I get lambda m proportional to 1 by pi d square mu. Okay, this is the one relation for the mean free path, 1 by pi d square mu. And when we consider for all the particle, then we get this proportional constant as root 2. So 1 by root 2 pi d square mu. This formula you have to remember, lambda m equal to 1 by root 2 pi d square mu, 1 by root 2 pi d square mu, 1 by root 2 pi d square mu. This is the formula for lambda m, 1 by root 2 pi d square mu. Okay, 1 by root 2 pi d square mu. Okay. Yes. Now, sometimes they will say if only one particle moving. This is the main formula that you remember. Most of the time they are asking this question only based on the formula. If sometimes they will say if only one molecule moving, and if only one molecule moving, okay, then we can write lambda m formula will be, okay. So in place of root 2 there will be 1. Okay, so we can write 1 by pi d square mu. But this is, keep this one as the question. Main formula is 1 by root 2 pi d square mu. Okay. This is the main formula. Okay. This one you have to remember. Can I say this thing also, lambda m proportional to V? True or false? Lambda m proportional to V. Because you know lambda m proportional to your V or inversely proportional to N. If I say more number of molecules, then lambda m will be less. Okay. So in this one, if I say the graph, then we can say lambda m and V graph will be the like this. Okay. So lambda m depends on the volume and number of molecules. That's it. Okay. Lambda m depends on the volume and the number. That's it. Okay. That's it. Okay. If I ask this question here, in a closed container, okay, in a closed container, temperature increased, then lambda m. In a closed container, temperature increased, then lambda m. What you will say? What will be the lambda m? It will change or will not change in a closed container. Okay, if temperature increased, then lambda m will change or will not change. Then we can say lambda m will not change. Okay, it will not change. It will remain same. Okay, it is not going to change. It will remain same. Okay, so we can write here lambda m will be same. Okay, and why it is same? What are the reason for this one? Because we know here volume is, okay, volume and volume and n same. Okay, V same and same. In the closed container, V and n will be same. That's why it is not changed. Okay, volume and number is same. Okay, now if I say second question, at constant temperature. So at constant temperature, you can say, sir, we have relation volume proportional to 1 by P. But this relation is only at the constant temperature. So I can write lambda m proportional to 1 by P. But lambda m proportional to 1 by P means if means graph of this one lambda m P here like this. But this is always valid or only at the constant temperature? This one is always valid or only at the constant temperature? Yes, only at the constant temperature. If temperature is not given constant, then don't use this one. Okay, Don't use, okay, only at the constant temperature. Same way you can say, sir, you can write third condition at the constant okay, pressure, at the constant pressure. This was the question of the constant volume. Constant volume, there is no change, okay. Constant pressure, we can say, sir, volume proportional to T. So I can say lambda m proportional to T. So here graph will be basically your lambda m and T, okay, means directly proportional. If I change temperature, lambda m will change always. If I change temperature, then lambda m will change always. True or false? If temperature change, lambda m will change always? No, lambda m will not change always, okay? When they have given constant pressure, then only will take the relation. Then only you will consider this relation, okay? Whenever they have given constant pressure, then only will take this relation, okay? I hope these graphs are clear, okay? And these two relation that is written here is not always at certain condition here, okay? Here constant temperature, here constant pressure, okay? Now, if I say what would be the time between collision, okay, so we can write time between, okay, if somewhere they ask, okay, because particle is, okay, before making the collision, molecule travels some distance, and how to find how much time it will take from here to here. So we can say time is always given by distance divided by velocity. They travel distance lambda with the velocity of vrms. So this time is basically given by means okay, time is given by distance divided by vrms. So we can say lambda m by vrms, okay. Sometimes they will ask what will be the, okay, your collision frequency, okay. And if they are asking about the collision frequency, then we can say collision frequency is always equal to 1 by time, and that becomes here, okay, just 1 by time if I write, then V RMS by lambda m, okay. Yes, these things clear? Okay. If I say somewhere I might have told to you that real gases behave like ideal gas. Real gases behave like ideal gas. Okay. At which temperature? High temperature. Do you know this thing? This is a statement. Real gas, I will write here, okay. Real gas, this is already written also, okay, behave like, okay, ideal gas at high temperature, low pressure and low density, okay. This is the thing that was told to you, high pressure, low, okay. Real gases behaves like this. Do you remember? So if I increase temperature, then it will approach towards ideal behavior. When temperature is high, it will have, okay, it will be moving towards ideal behavior. And here we got one graph. This graph is common to physics as well as chemistry. This is the PV by KT, and here we got, okay, that this line represents the ideal behavior, means this is for the ideal gas, okay. And now we can say one graph given like, okay, and one graph they have given this way. This one is the A and this one is the B. You can say A is having this much deviation and B is having more deviation from the ideal nature, okay, A and B. So if I keep on increasing the temperature, then they will approach towards ideal behavior. When temperature will keep on increasing, they will approach towards ideal behavior. So if I increase the temperature, then they will be very close. And when means which one is close to the ideal behavior, that is having more temperature or less temperature? Which is very close to ideal behavior means temperature is, which one is very close to the ideal behavior means temperature is high, okay. Temperature is more, which is close to the ideal behavior, temperature is more. Sort of this one you have to tell me, okay, which is very close to the ideal behavior, which is very close to the ideal behavior, A or B? We can say A is very close to the ideal behavior. So which is having more temperature? We can say temperature of A is more than temperature of B. Okay, temperature of A is more than temperature of B. Done. Okay, so for this week syllabus is over. Specific heat will write in the thermodynamics. Okay, not here. Okay, in thermodynamics part will write the your specific heat things. Now, okay, do your all the questions. Okay, all the questions you can okay do. Yes. Anything you want to ask? You want to ask anything? You want to ask anything? Specific heat, gamma, okay, Cp by Cv, these questions you don't have to do. If you want to ask something, then you can ask. I will explain. Okay. Some questions. Which question can you tell? Syam, which type of question, which variety of the question not came? Which one? I will give some idea. You have my number, otherwise you can, okay, message. I will give some hint if you are, okay, not getting some answers, okay. But first fight with the question. Your fight is always required, but ultimately in the examination you have to fight, okay. So here you need to fight with the question. Once you become very strong, examination will become very easy to you, okay. So if any doubt is there, you can always message to me, okay. Yes. And if I don't reply, sometimes it may happen 1 hour, okay, 1-2 times. If I don't reply, okay, don't feel bad that sir, okay, sir is saying that, okay, message to me, but okay, no response, okay. Sometimes, okay, means I might be busy also, okay. So okay, you can remind me, okay, if anything is there. Number, you know, okay, number is there, okay, already you know. Okay. And don't send me okay, sometimes I see that people send okay, doubts in Instagram also, okay. So not on the Instagram, okay, in the number you can do the things, okay. It'll be better, okay. Sometimes people say, sir, you are not responding in the WhatsApp, that's why I'm sending in the Instagram. But ultimately, okay, whenever you will send, either anyway, I will, okay, either you are sending in WhatsApp, either Instagram, or anywhere, okay, mail or anything, okay, your doubt will be cleared, okay. Yes. Temperature at which RMS velocity of molecule of helium is equal to RMS of hydrogen. This is the question here. Someone has sent me. Let me say the question here. Okay. They are saying in this one, temperature at which RMS velocity of the molecule of helium is equal to RMS of. So we can say in this one, okay, V RMS of, okay, helium, okay, equal to V RMS of H2, okay. So we can say root of 3R T1 by MW1 equal to, we can say, root of 3R T2 by MW2. This concept was told to you. Squaring both sides, root will be cancelled, 3R will be cancelled. So we can say T1 by MW1 will be equal to T2 by MW2, okay. Now we can say T1, you have to find MW1 for the helium 4, T2 is given, and Tp is 273, okay. 273 and MW2 is 2. Now I hope you can solve. Okay. Answer will be in the Kelvin, then you have to convert into degree Celsius. Done. Okay. Finished. Okay. So do all the questions. If any problem, you can ask me all the time. Okay. Don't worry about anything. Okay. Only thing that you need to say, sir, this is the problem, we'll discuss the things, and okay, prepare all the things and do all the question in the examination, okay, all, okay, your preparation, because in the beginning, if you are getting more marks, okay, later on you have to work hard just to maintain the marks, okay. So in the beginning, we need to get higher marks, okay. So try to get all the time, okay, 650 plus will be the target for you, okay. Make 650 plus, and you have to just get out of 800. So you think that out of 720 you have to get, out of 800 you have to get, okay, out of 800, okay, 650 plus is your target, okay. Okay, so bye, okay, bye, enjoy.